So last year I gave a lightning talk, so this is the thunder talk because I like to think that I'm clever. So Brian Schott, I wrote several of these tools that some of you might know about, and I also complain on the forums, but that doesn't make me special. So my GitHub handle is HackerPilot. Reasoning behind that is I used to be a pilot. I used to fly stuff like that. These days I just fly simulators. And I've noticed a few things that aviation and programming have in common. One of them is that Hollywood has absolutely no idea how any of it works. And two is that computers and airplanes are really good magnifiers for mistakes. If you make a little mistake and it involves an airplane, it's a big mistake. And if you make a mistake with a computer, you've made 1 million mistakes in a second. Try doing that by yourself. So, D in the real world. So I work at a company called Economic Modeling Specialists International. Please don't blame them for any stupid things that I say during this presentation. But we do have a position open. You can get a job writing D code and get paid for it. It's no longer science fiction. This is real life. So compiler updates in our code at MZ looks kind of like this. So the blue part is using dust mites to narrow down compiler regressions because of all the crazy template code that we have. The yellow part there is due to API changes, and the green part is due to deprecations. Does this work? Yes, it does. The one thing that works. Thank you, Logitech. Okay, so the first tool that I'll be going over is dformat, which you heard mentioned in a previous presentation, and it formats D source code, and certainly doesn't get bogged down in silly arguments. So how do you write a code formatter? So when I first started this, I had a few bad ideas. First one is leverage multiverse theory. And the idea here is you go to an alternate dimension and obtain the correct code formatting from a version of yourself that has already done it for you. You communicate back and forth through interdimensional message passing because nobody wants to deal with synchronization issues. And this doesn't work because the only Brian that managed to figure out how to get it to work uses the GNU brace style, and none of the other infinite possibility Brians use that, so dead end. Next idea is facial recognition, symptom, and analysis. So you have your laptop with a webcam. The webcam is facing at you. You turn it on. It reformats your code, figures out that you look really angry, tries it again a different way, and that's how it trains the algorithm. So the problem with this is it requires a webcam, and you can't put this on a server and run it. So yeah, that's not going to work. Next idea is mind reading, but that's stupid. So that goes on the list of bad ideas. The really important one here is that MySQL bind result part. The API documentation tells you that you need to call these functions in a loop. So you think, okay, it's in a loop. It's not going to hold on to this, is it? You have to give it a pointer every time. This is wrong. If you do this, you'll get stack corruption and functions completely unrelated to your database code. And it will crash, or it won't. That's the best thing. So yeah, bad ideas. So let's go on to good ideas. Lots of special casing, some configuration options because people don't agree on how you should format code, more special casing, and lots of regression tests. I think we're up to 155 or so, roughly, right now. And then more special cases. So the way that it actually works is you have a kind of pre-processing step. It runs the lexer, and then it keeps kind of track of each token. What's the depth, like how many parentheses are we inside of, how many brackets, and so on. It does a parsing step because D is complicated enough. You can't tell if you're declaring a pointer or if you're multiplying numbers, that sort of thing. There are a lot of cases like that. New line style detection shouldn't be on the slide yet because I haven't implemented it. Everything is Unix line endings because they're right. Next step is using that information you've collected, you iterate over all the tokens, use all those special cases and the switch statements, The line wrapping is based on a kind of A-star inspired algorithm. So it takes that parentheses and bracket nesting depth that you got at the first step, and it uses that to inform, okay, is there a lower cost or a higher cost to breaking a line at this spot? And then it does things like, is it better to go over the soft limit by a little bit than it is to break onto another line? And some of this works, most of it. But of course, people are still finding cases where it doesn't give the results they expected. And still going back to that webcam idea, it might work. So there's several options. They're all documented on the project's homepage. It uses editor config files for configuration, and most of your projects probably have an editor config file. If they don't, they probably should, because most text editors will support this, and you can keep the style consistent. And it uses standard in and standard out, so you can pipe it through a text editor or anything else. Next is DCD, because you're far too late for an IDE. I know I am. So it provides these things: code completion, go to declaration, function call tips when you enter left parentheses, import completion. It has the list of predefined traits, versions, pragmas, and so on. So it will give you autocomplete on that stuff. So what does this look like? Well, what it looks like is a command line program that's not very exciting to look at. Where's my, oh, there's the mouse cursor. So let's see, if I go here, completes tells me that that's a variable, but where is that? So I can use go to declaration, and that works. And if I ask for autocomplete right there, it gives me a call tip, which goes off the screen because I have a giant font size for the presentation. So all of this is handled with a editor-independent client-server system. There are plugins for Sublime Text, Vim, Emacs, everything. Well, and if there isn't one, you can write it. So as a client, basically it's a standard text interface. You just give it some code through standard in, and it gives you an autocomplete list on standard out. Then your editor plugin reads that list and shows it to you, if it's working properly. So then the server actually does everything else. It handles all the lexing, parsing, it keeps a cache of all the symbols that it's found, and it does the autocomplete list. Then the last part of this is of course the plugins, and each editor is going to need their own. I only maintain the plugin for an editor called TextAdept, which a lot of people have not heard of. But there are plugins for lots of other editors that people actually use. So yeah, symbol cache, and then every time semantic analysis is misspelled with regard to DCD, that's intentional because it is really dumb. It looks at the AST and gets just enough information to say this is a thing that's a struct and it has this name and it was declared here, and that's really all it knows. So the communication between the client and server is done over local IP, and then the actual message format is message pack. So if you want to, you don't have to use the DCD client. You could implement this in an editor plugin or an IDE. Quick note on allocators. So when I was writing DCD, I ran into several performance problems. One is that it would use way too much memory, and two is that it would be slow. So I started using an experimental version of standard.allocator, and this made things much better after I got rid of all of the bugs that caused it to crash. So why was it crashing? The reason is that you have the classic issue that the garbage collector doesn't know about memory that's been allocated, or if you have pointers to garbage collected memory and the pointers themselves are not registered with the garbage collector, it starts going and freeing all of your memory while you're still using it, and this is bad. So I think one of the really important things we need to do with the Allocators API is make sure that we have some way of tracking this information or saying auto-register with this with the GC so I don't lose everything.
Or just don't allocate memory.
Yeah, or just don't allocate memory. I'll just get rid of the symbol cache and rescan all of Phobos every time you ask for autocomplete. Oh, incidentally, that's what this system used to do. DCD originally was part of a program called DScanner, which I'll get to later, and it actually did rescan everything every time you asked for autocomplete. I'm really glad it doesn't do that anymore. I think anyone using the program is also glad. I really hate the name of this project. Yeah. Like, well, we need a documentation generator thing. Documentation docs is where boats are harbored. Sure, stick that name on it, ship it. So why did we do this? The reason is that if you use the normal compiler implementation of DDoc, it does source and then some other stuff, and then it gives you the docs at the end. And that does a few things like accidentally converting all of your size t parameters to unsigned long or something else, depending on which platform you generate the documentation on. Or at least it did that at the time. I'm not sure if that bug's still present. This just does source to AST to documentation. So again, you don't have that. You're not limited to the information that's present in the JSON output. And you can still generate documentation without having to specify all of the include paths and make sure that your code is semantically correct and links and all of that. Or I guess not links, but the rest of that. If you leave off the include paths, the compile will fail and not really spit out your documentation. So that's why we have that. Is anyone familiar with what this is? You got at least one? Oh, nice, you have the shirt. Okay. So what's that in the corner in the first fire group? DScanner. I thought that was an amusing coincidence. I think I got the name first before they did, but I don't know if it was in a previous version of the game. Anyways, so DScanner is a kind of multi-purpose de-analysis tool. So it can give you an outline of your code. Like if you have an IDE and you want to give like a tree view of all the code, DScanner will be able to spit that out. It can output C tags and E tags information for you. If you want to know where something is defined, you can just ask it. For example, let's go, no, we're not touching this. So it looks for the declaration of main and check and source, and it gives us the line number, column number, and the file. And then let's try this. So there's C tags for the unused variable finder. And then say we want an outline of that file. So here it's listing all the declarations, and its the indentation is by scopes, and it tells you what it is and what line it's on. The other thing it will do is if you want to get a dump of the AST of your program, it will do that. It'll take your source file in and give you a giant XML monstrosity out. It'll also do syntax checking because it has a parser in it. Source line of code count, it will give you an import list, and this is just a really simple one. It looks through the AST, finds all the import statements, and lists them one per line. So if you want to build a dependency graph of some source code, you can just run DScanner on all the files, and it will give you the information you need to try to put that together.
So I have a question about that.
Yeah.
So I know that in DMD, you can actually give it a flag and it will output all of the import dependencies for you. In the talk that I've prepared for DConference here, I made a dependency graph just from information from DMD. So is there a difference between the import list that you've implemented here, DScanner and DMD?
I think the only difference is that I did this before DMD had that feature,
Okay.
and it probably doesn't need to be there anymore.
Okay.
So I also found that out with one of the static analysis warnings that I had in there about the old floating point operators. So those used to compile without any errors or warnings, but now they're a warning, unless I'm mistaken. So I can probably delete that check. Yeah, good question. So it can also take the results of the Lexer outputted HTML if you don't want to use some sort of highlight.js library for some reason. And then the big feature is it will do some static analysis and linting checks. So what is this? This is a struct with a constructor that has a single default argument. So what does that default argument do? Exactly, it does nothing. So why is it there? And why doesn't the compiler tell you that it doesn't do anything? So DScanner will check that. It will tell you you have a constructor, single default argument. Probably shouldn't do that because it's confusing to anyone who reads your code. If you write this code, you are a bad person. You really need more parentheses in there, or in that case on the far right, fewer parentheses. It's a pretty simple check of the AST to point that stuff out. This is kind of confusing because the thing that's being returned from this function is not const. The function itself is const. So it will give you a warning saying you should probably move that. And then if you're really committed to this whole cleaning up code thing, Defects will actually move it for you. But I'll get to that later. And next, if you have a function that takes two variables and you only use one of them, that's also confusing to anyone reading your code. And it will give you a warning that variable B is unused. There is some logic in there that if you have, say, int a, comma, and then int, and then the closed parentheses, like you never give the second variable a name, then it's not going to give you that warning. And then there's this nonsense. Yeah, you shouldn't be doing this. At least the first one you shouldn't, because Windows doesn't really handle case sensitivity very well. And just in general, these don't comply with the Phobos style guide. So that was pretty simple to implement with a regular expression. Next, what does this do?
Does it compile? Nothing. Well,
It does compile, and it does nothing.
yes. I mean, yeah.
What you actually want is for each reverse. This is silly, but sometimes it happens when you're doing a bunch of refactoring. You accidentally end up with two branches of a conditional being identical. And this is a warning in DScanner. Once you have all this information, what do you do with it? Well, DScanner can output a JSON report of all the things that it found. And then I wrote a plugin in Java for a system called SonarQube. So that's kind of a static analysis or code quality metrics dashboard thing used in several organizations. So it can take that report, upload it to SonarQube, and then you can see all of your code quality issues in the same place that you would look for, say, Java reports from Find Bugs or PMD or something like that. And this is built into the CI process for D projects at MZ. At least almost all of them. We still have a few. Still have a few that need to get that running. So here's a screenshot, and you can see all the things from DScanner showing up in SonarQube. Really exciting. So what is all of this stuff built on? It's built on libdparse, which is the Lexer, Parser, and AST library that I built for all of this. And here is a conversation that occurred on the news groups. I'm not going to name any names, but both of these people are presenting at the conference, so you can narrow it down a little bit. You know who you are. So, lexing. I have a lexer generator. I guess everybody has a lexer generator, but this is the one that I wrote. I've used it for lexing JSON, Lua, and D. Lua and JSON mostly just to prove that I could, like I wasn't building any D-specific things into it. And then on top of that, I have a D-specific lexer that's using that generator. So because the lexer is the core of basically everything, it needs to go fast. So first step in optimizing D code is don't use the reference compiler. Second step is use perf and look at the reports and study them. Next step is use perf again. Really measure this stuff. And then another optimization I found is instead of mixing in a giant switch statement, you can actually mix in a binary search kind of thing. Like if the byte that you're looking at is less than this, go here. If it's more, go there. And that ended up giving a fairly decent speed improvement. And then after that, SIMD instructions. So SIMD instructions are fun. With the 128-bit registers, you can measure 16 things at a time. With the SSE 4. Of course, I probably made a mistake in there. Maybe. Did I? Okay, SSE 4.2. These have the interesting instructions. There's the unreadable version on the left and then what it actually means. This one was really promising, I thought. Doing a substring search, so I have a giant string literal and I want to blast through it as fast as possible, but string literals can be escaped. How do I know that I found a double quote that's not escaped? So that's easy. I just look for, escaped slashes and then single quotes and then escaped quotes and figure out the masks for those matches. And the problem is that looking for this double backslash, it matches here and here. It doesn't match in just one place. It matches in both of them. So when the instruction says that it checks for string matches in parallel, it means parallel. It doesn't know about the previous match. It has no clue about that whatsoever, so this doesn't work. I worked through a few algorithms that I thought would let me use this instruction, and they don't work. But they looked like they worked for about 3 days while I was, typing them up and writing test cases, and then, at the end of a few days of work, I'm like, yeah, I haven't been able to get this to work. If you know of a way, please let me know. So what does work? First of all, any of these shortcuts that you make using SIMD instructions, implement those algorithms so that they can do useful work or they can do nothing, and that won't influence the rest of it. So that way you can put your SIMD stuff inside of a version block, and if the version is disabled, everything works correctly, it just may not work as fast. Like if you want to bulk skip a whole bunch of things that you know are not possibly the end of a string literal, and then handle the things that might be at the end, you could get rid of step 1, and it'll still be correct, just maybe not as fast. So once you have a lexer, you need a parser. Eventually I ended up making this project called Generated, and during this whole process of making a parser, I was going through the official language specification and what kind of code was out there and what the reference compiler did and how none of them agreed with each other. So I started making my own reference grammar for the language. And then I decided, well, if I have a parser and I have the grammar, I should probably make a generator and make sure that the whole loop actually is consistent with itself. And this generates really ugly code. You only really care about this if you're writing an IDE plugin or something like that. Everyone else won't care. So issue 10233, we doesn't grammar good. So there were a lot of bugs that people have found with the official language grammar. The good news is that most of them are being fixed. And some of the remaining ones, I'm not sure how he fixed them without breaking some code. So here's a bit of interesting code. That first declaration, first right there, it's a void function first of arrays that takes an alias and 2 ints, and it's equal to that function, or struct literal, no function, right there. Now, I don't know what that actually is, so I had pragma message and typeof to help me, and it says void. So if you write this, some sane code right here, it will tell you void function that takes 2 ints, which is completely reasonable. Which really makes you wonder about the first one. Void? Fortunately, if you enable warnings, it will tell you use dstyle syntax void function and then that. I didn't even know you could put extra argument lists or template arguments there. I guess you can. This is a work of pure genius. You can take uniform function call syntax and property syntax and combine them together, and it'll actually work. It is defined. This isn't undefined behavior. It's in the language spec that you can do this, and I did find an interesting use case for it. But you can use it like this. Uniform function call syntax, write-f line, and then a tuple equals, and then a string, and then all that in parentheses, and then you expand it and assign that to write line. Anyways. Huh?
It then actually works for us.
So DIP42 is the abbreviated template syntax, which I think was a good idea. Problem is that the change in the compiler that allowed that to happen also allowed you to templatize every variable declaration. Please don't use this. Okay, so in D, you can do void function x equals and then an expression to initialize it. Or because we're in D, you don't have to write the type. You can just use the expression like that. And if you do this, the compiler says that this is perfectly fine. Or not. Struct initializer, but that's a function. Right up there, it's a function. But now it's not. And then you investigate this a little further, and it gets a bit more weird. Like this one is templated, that one is not. They have the same initializer. Okay. So, expressions. So you can say there's an int a equals 10, and if you just say 10, that's nonsense. Like, what does that even do? You can't just say 10. If I walk up to you and say 10, you're going to look at me like I'm an idiot. So that doesn't work. And then if you use a, it also doesn't work. However, if it's a function, it does work. So what if we have a variable that is a function? That doesn't work. You have to call it. So what does this do? Can you put the expression, the function literal right there, semicolon, and have that be a statement? Like, can you just walk up to the compiler and say, function literal? So does that write line run? No, of course not, because it's just an expression, and you've just said expression. And it does run, because the parser makes an exception for this case, I guess, because it's a block statement with an empty statement after it, not taking the maximum possible match. Not really consistent. So, infinite loops. Let's see, how much time do I have? Not too much. Yeah. So you can do while true, you can do for 2 semicolons, and then you can do 4 braces and then a single semicolon. This is perfectly normal. You can add parentheses, it does the same thing. You can do a try and catch. And then if you add parentheses, it does the same thing, except that it doesn't. It tries to catch standard error and call the global scoped write line, which raises an interesting question. If you caught standard error, what would you do with it? I don't know. Okay, last one, aliases. Abbreviated grammar here, identifier equals type. So you also have an enhancement request that came through a while back, so you can say super and then a symbol. And then that led to these two issues where you could say class and then inherits from super, and nobody knew what that meant. That I think is an error now, but it should have been caught at the parsing stage. So aliases for types or other symbols, and symbols are not necessarily types, because some symbols are actually tuple index expressions. And I'm not sure if this pull request was merged, but there's another special case added to the parser for this. It's gotten a little out of hand. So you're saying, okay, all these parser issues are just a one-time cost. You fix them once and then they're over with forever. But I would have to disagree, because every IDE has its own parser framework. And if you want all the code highlighting to work properly and you want all the syntax stuff to work inside of that IDE, you're going to have to re-implement the parser in their special magical language framework. Same thing is true with Sonar. If you want all of your D code to be highlighted in a Sonar report, you still have to re-implement some of the Lexer definition there. Regular expression-based tools are another reason. For instance, this example using HereDoc, which highlights perfectly correctly. You can tell because the int and the I are all, and the comment are all strings. So we need to fix this. And then the question is, can we fix this? Yes, we can. The Defects project is something I started, and it can fix alias styles, it can fix implicit string concatenation, it will fix the conversion of C style arrays to D style automatically. Has support for attributes. That's a completely different talk. Catch clarification, where if you have catch nothing, it should be catch throwable to make it explicit what it's actually doing. And it also fixes that parser bug where if you have parentheses right after catch, it assumes it's an exception without seeing to see if it's a whole statement after it. And then it will automatically move const immutable and out and so on from the left side of a function off to the right. I don't think we have time for this. Automated code upgrades. So if we have mistakes, if we made bad decisions, we shouldn't be stuck to them. So we already have a language for people who want a language like C++ that sticks with backwards compatibility forever, and it's called C++. It's already there. So, the future. So, one thing I think we could do is experiment with AFL fuzzer. That has some instrumentation that's injected into the code. Right now you can use this with D programs, but it doesn't work very well because AFL takes the assembly code, makes some modifications, and then sticks it back into your build process. But I think with GDC we might be able to get this to work. That's just an idea. Other ideas are more checks in DScanner. So I've already started taking some of the symbol lookup code out of DCD. So now some of these more advanced checks will be possible. Like if you have a function with 3 arguments and then you have 3 parameters and the names are the same but the order is different, you'd probably want a warning about that. Labels with the same name as variables. I don't know why the compiler accepts that, but it does. The implicit cast of arrays to booleans. Yeah, that was a fun forum discussion. I still owe somebody a table flip for that. Assigning to non-ref for each variables. Not a good idea. Check for unused imports. Okay, smarter defix. So using that same stuff I talked about from DCD, we can keep the existing functionality, which is to upgrade from one version to the next. Or we could say defix rename and then, for example, fix that silly type tuple nonsense forever. Because if you have enough information to say, this identifier here is actually that symbol, you can do a rename pretty easily. Okay, so here's what I think we could do. Defix bot. This is my evil master plan to take over the world. So step 1 is create a GitHub account for this thing. That's already done. Step 2 is the hard part, where we decide that we are going to fix things if they're broken. Then we scrape code.dlang.org for GitHub URLs. Next step, clone everything. Create branches, run defix, push to defixbot's account. Then we use GitHub's API to make pull requests. There is an API for this. We can do this. There is no question mark step. Profit. The other version of the future is this. We could end up with this. Hopefully not. Okay, image credits for stuff I've stolen shamelessly. And that is the end. I think I've gotten on time, so I have time for a few questions. I think.
Okay, so the question was regarding the context of the fixed scanner DCD. Have you considered separating the kind of partial semantic analysis part from the scanner DCD to separate library as part of libdparse?
It's on GitHub right now,
Oh,
but I haven't
sorry.
advertised it yet because it doesn't work.
Oh, okay, yes. Yes, that answers my question. Thank you.
Isn't this ultimately limited by the fact that you don't have, full semantic analysis? So, for example, mix-ins, stuff like that. Somebody does a string mix-in of a function or something. Defects can't do anything about that, can it? Not
No.
unless it had basically a DMD's parser.
Right.
Which doesn't that limit the scope for using these tools for automatic upgrades, because the fact is there's a lot of generic code, which is, these sort of generated code that by definition can be some of the hardest to maintain code.
Yeah, if you have a whole bunch of references to symbols inside of string mix-ins, then yes, you will run into problems. The point here is that you can get a lot of value out of this small amount of effort. And then the remaining cases you can fix up manually. But the idea is that this will fix most of the problems very quickly. Any other questions? Right, I think I'm done.